Hello. So we are looking at the simple video driver, and I thought I would just run through creating a small application to display some text and graphics, something you might want to do for your own project. So we'll just very quickly look at the hardware we're using. So it's the P2 Edge module 32 megabyte. Very important to have the Edge module with the RAM chips on board. And then I'm just running it through a mini breakout board with the digital video out accessory to provide us with the HDMI cable. I've got the HDMI plugged into this small 7-inch screen here, but you could use a TV or monitor as well. And then the usual things just for programming and powering. Power is coming through a 5-volt USB barrel jack from a USB 1 amp charger because I'm powering the screen as well from the same supply. So needed a bit more juice. And that's all, not using the VGA here, although you could plug in the VGA and use the VGA monitor instead as well if you wish. So let's take a look at the code, which is here. I'm going to rattle through this as quickly as possible, but really just wanting to give you an overview of how you can set things up yourself and experiment and roughly what things do. But by all means, ask questions for further details on the forums anytime or in the comments section on our Quick Bytes page. So we have this solar panel monitor demo sort of framework. It's similar to the previous one we had for the character map. And so, yeah, set the base pin. These are the user settings. So you set your base pin. I've got the HDMI breakout plugged into base pin 8, IO pin 8. And choose the video mode. So I'm going to go with 800 by 600 just for demonstration now, although I'll switch it to a smaller resolution later to run it on the small monitor. The other settings here you can just leave alone. The clock settings, various global variables that we're using. The objects are the same. Video refers to the simple video driver. We've got nstring, string handling library, and a list of color codes or color names. You can open up these objects. Just go File, Open, and you should find them in the same folder as the as what as what we've given you to download. And you can always look in there. So here's the colors. You can see what the color names are. These are the string handling functions, and you can look in there and see a description of what they do and how you can use them. Again, with simple video, you can look in there and there's all of the functions, which are the public functions. They're all described with the arguments, so you can go in there and figure out how to use them. So on with the program. So here's the main routine. This will get called when the code first loads. We initialize the hardware using the settings, the constant settings that we've set, the con settings that we've set up here. And then we set the background color to color white. And that's job done, really. From then, we just repeat in a loop, updating the display once every 1,000 milliseconds or once every second. And then do lots of other interesting stuff here. So at this point, the cog could be doing lots of other interesting stuff. And also just to note that we are running this on the P2 that has 8 cogs, 8 processors, and we're not using, well, we're using 2 of them. So yeah, the other 6 could also be doing lots of data collection and input-output stuff and all sorts of interesting things, or driving a multitude of other displays if you wanted. Anyway, so we're going to write the update display sub-function that we've just made up the name for and seemed like a pretty name. So let's do that. So we'll start by setting out some areas. So we'll say header, content, and footer. So let's sort of lay it out as if it's sort of a web page. Now, I've previously got this sort of figured out, so we'll just paste in from a previous example. So image, we're going to load the image. This is the first function. We're going to set the X and Y location for where we start drawing the image from on the screen. So we want to do it bottom right. So it's going to be the X size, X size is the monitor size, so we've set that above. We told it was 800 by 600, so it's 800 on the x-axis, 800 wide, 600 on the y-axis, so 600 tall. So the x size is therefore a constant that refers to 800 in this case, as that's our screen size. So we just have the 800 minus 300, which is the width of the logo. So it means that we're going to be 300 pixels in from the end of the line, which gives us 300 pixels width or space to draw the logo in. Same sort of deal with the Y size. So the Y size is 600 in our case, 600 tall. So we're gonna say 600 at the bottom, but minus 57. Just come up 57 pixels from the bottom, which is the height of the logo. So it gives us a space to draw the logo in. So that's how the coordinate system works. And then we've just got the logo address, which we've nominated. We've given it that name down at the bottom of the code. And that's loading a logo. We can just quickly look at the bottom of the code where we load the logo. And here it is, logo image, file, and that's the file name. So let's go back up. Right, so after we load the image, we also draw a line, and draw line H for horizontal. And it does what it sounds like. So we start at 0, which is the left-hand corner or left-hand side of the screen, and we start at this position. So again, Y size, the bottom of the screen, minus 57, which is the height of the logo earlier, and then minus 8, just for a bit of arbitrary padding. Just whatever number you think looks nice on screen, I suppose. I thought 8 looked quite nice. So that's our position that we start drawing our horizontal line from, and then lengthwise it goes all the way across the screen, so it's 800 pixels wide or long. That's our color, and that's the thickness of our line. So that just gives us a sort of a dividing line just above the logo, because we've drawn it, we've deducted the height of the logo, and we've also deducted a little bit more just to go slightly above the logo. Right, so let's load that into the I'll do Control R. We'll just load that into the device, and I need to turn on the output. There we go. So we can see the output on the screen now, coming live from the P2. So there's our logo and there's our line. Simple stuff so far. So that will do for our header. I won't embellish that one anymore. And now we'll add some. Let's add the header next, because that's relatively simple. So we'll just use one that I made earlier, just for speed. Here we go. So the header is a similar sort of deal. We draw a couple of lines and we write some text. So writing text is obviously a new thing now. So drawing the lines is just as before. So we've got 0, 0 is the origin for the first line. So that is top left. That's 0, 0. The length is the length of the whole line, so 800 pixels long all the way across. We're going to have a color of super dark orange, and the line width is going to be 52. So essentially we're going to end up with a line that's 52 pixels tall all the way across the screen. And then after that line we draw another line, just to give it a nice crisp edge, so a black line, and we position it 52 pixels down on the y-axis. So you can see what's going on here. We're telling it to draw 52 down, so it would just be at the bottom of this wide orange band. And the black line will be 3 pixels wide as well. And then finally we just write some text. So the text again uses the same coordinate system. Put your X and Y in. This is the origin point of your object on the screen. So we're just going to go 10 pixels in, just to give a little bit of padding from the screen edge. And we're going to have 10 pixels down. Again, it's a little bit of padding. And also it just, that works out to be halfway. So the reason I chose 52 for the background is because the font we're using, which is font number 2, a large font, is 32 pixels tall. The font is 32 pixels. If you add a padding of 10 either side, you get 52. And so that's why that's why I sort of went with those numbers, just to try and get it nice and centered. And then the color, when you're writing text, you can choose both foreground and background color. Now, in this case, I've chosen them both to be black. Um, it doesn't matter actually that they're both black, but it does matter they're both the same. If the colors are both the same, it means it writes the text um, with a transparent background. So essentially, whatever was underneath that text will still be there. So you can write text over images, over colors, and it won't interfere with them. And that's what we want to do here because we don't want to interfere with our header background. Although actually we could, because in this case the header background is actually dark orange, so we know the color. So we could say our background is dark orange and it will look just the same. But anyway, let's just leave it as transparent text for now. And then finally false. Let's actually change that one to true because that last option on the right text will add a shadow to the text. So as this is a title, let's add a shadow just for fun. So I think that was actually off your video screen, but anyway, there you go. So it's the two colors, and then the true or false option at the end is for the shadow. So that is our heading. Well, let's load that up to the device because that's the good thing about the P2. You can just upload it. There you go. Control R, and straight away we can see our changes. So there's our heading, complete with shadow. Not sure if I actually like the shadow, so maybe I just change that back to false and upload that again. And let's see how that looks without the shadow. Okay, well, I'm not sure now. Let's leave it without the shadow as we are. And you can see the orange line or the orange background, 52 pixels tall, and you can see the black line just crisping the edge at the bottom of it. So that's our page layout. Simple so far. And, well, content we've got next. So, there was one other thing I wanted to add to the header, actually, because we are refreshing once every second. I thought it might be nice to have a clock. So let's just add that. So we're going to write text. We just set the X and Y again. It's just, it's the Y-axis is 10, the same as the previous one. So we're writing it on the same line. We just write it. We do a bit of math just to calculate where it's going to be at the end of the line. You can ask about that on the forums if you're not sure about how to, how these calculations are working out. But if you kind of figure it out on pen and paper, it'll come to you. The important thing to know when you're playing around with font gaps or spacings is to know the font dimensions in pixels. So let's say this font is 16 by 32. So that's why you'll see these curious calculations here and there that feature the numbers 16 and 32 because that is, the font size in this case. Now you could actually, here you could just write the actual number that it is. And no problem doing that at all either. Just that as we develop code, it's just sort of a habit to put the to put the equation in here, because then you can see what you've done. So you can easily tweak it later if you want to. So here, for example, we had the video exercise. We've deducted the 10, which is the same padding as we used earlier, just so it balances on the screen, make it visually nice to have the padding on the left and the far right to be the same. And then we've deducted the length of the time that we're going to show in a minute. And the time is made up of 5 characters because it's 2 digits, the colon in the middle, and then another 2 digits. So it's 5 characters. And we just multiply that by the width of each character in pixels, which is 16 pixels in this case. So that's how that's constructed. Yeah. So you'll get used to doing things like that. And then Y is down. Get time is just calling a helper function down the end, which is calling up a string representation of what the current time is. Font number is, again, large font number 2. And we just set the colors. And we do not want a shadow. So let's just upload that to the P2. And that should now show us the clock ticking in the corner. There you go. Right, so content. Let's see if there's anything new that I'm using in the content. So to start with in the content, I just set up some variables. This is just, it just makes things easier to refer to things by name. The the image width is 95 pixels wide. I want 8 boxes along one line. You'll see that in a moment. And I just set up some padding and margins just to space things out in and it's automatically calculated so that if I change the video settings up here later, then the spacing will automatically adjust itself for the new screen environment. And then finally, the total watts, I just set that to 0 because every time we call this loop, I want to add up the total watts output, the output from each panel. So what we do is have a first row of boxes. So we'll just pop those in there. Now this seems like a lot, and I won't really go into it, but suffice to say that we're setting the Y position and then we're repeating through a loop, the Y position being on screen. So we want to be 100 pixels down from the 0 point, which is the top of the screen. And we are repeating the X position from 0 to 8, because, well, 0 to 8 minus 1, 0 to 7, but 0 to 7 equals 8, because we want to display 8 channels of data, basically 8 boxes. So this loop will just repeat 8 times, and we load the image for each one, which is I've called it data box, which is the solar panel background. I'll show you that in just a moment. And then we create a string that we're going to display in each box, which is essentially just the index number for the channel, some voltages. We read the voltage and put a V after it to denote voltage, and then we read the watts here, and then we write that to the display as well and put a W after it to denote watts. And then we use the video write text multiline command, so that's a new one, to put that on the screen. So what this does is, again, you set, I mean, there's all this complicated arithmetic here, but we were basically deciding on the position of the text. So for the x-axis, again for the y-axis, and we write the string, and we tell it that 5 characters wide. So because this is multi-line, it will automatically write text over multiple lines, and you just need to tell it how many characters you want per line, and it will just keep going down more lines until it's rendered all of the characters. So we want to have no more than 5 characters wide, and then the usual things: font number 2, foreground color, background color. I definitely want to use the same colors here because we want to have it transparent, because we're going to be writing this over the image that we've loaded above here. So yeah, hopefully that's understandable, but as I say, ask questions on the forum if you need anything explained any better than that, and give it a try and play with it. This string buffer, you'll see that when that string buffer is sort of created by the code, you'll essentially have, it'll clear the buffer, and then it will write x, which is the index from 0 to 8, or 0 to 7, sorry. And it pads it. It uses this pad string function, and it adds 5 or up to 5 spaces. So you'll have 1, 2, 3, 4, 5 spaces, but back a space because we've got the number 1 there. And then we have the voltage and then a V. So there'll be something like 37.4 V because it's using dp decimal. So it's that function. Again, you can look it up in the strings code what that's doing. But that function will basically give you a decimal output, a number with a decimal point. So it'll do that, and then it reads the watts, which might be 1448 watts or something like that, for example. So this code is basically going to create a string that looks like that. But then when the multi-line text reads it, because it splits every 5th character, it'll do something like this. So what you'll end up on the screen is basically something like that. Say play with it and you'll realize what's going on. So let's output that and see how it looks. Make sure I've got it right, and then we'll just get on to the last row. There you go. So now we can see we've got the pretty little solar panels in the background, and each solar panel we can see the voltage and the wattage coming out of it, updating each second. The solar panel image is very simply one of these things, and I've just drawn I just drew a grid of 16, so 16 by 16 pixels, and then I drew a box around it, of course with lovely rounded edges, why not? And then just added this solar panel kind of graphic background. Gave it a little bit of opacity, so it's not, not too dark, not too bright, somewhere in the middle. And then saved it without the grid. Get rid of the grid. There you go. Saved it, and that was a 95 by 95. Just went into bitmap, gave it a file name, save, and 8-bit depth, because that's what we want, as always, for importing images into Simple Video Driver. And OK, flatten. And that just gave us a 95 by 95 pixel square, basically, which we can use. Well, you can see on screen now. So I've used each zone is basically using this same graphic over and over just for efficiency. So what we want to do is add one more line. So let's just add a second row of boxes. And I'll just show you another technique in doing this. So second row of boxes essentially wants to be the same as the first row. We just, again, increment the y-axis because we want to come down another 100 pixels. We want to draw the next row of boxes below the first row of boxes. But essentially the code is the same other than that, apart from the fact that we've added 8 to each index value, because the first row is 0 to 7, the second row is going to be 8 to 15. Yeah, different solar panels in theory, so we just added 8 to the indexes here, but that's all. Otherwise the code's the same. But one thing you can see with using this write text multiline is that all the text is the same color, which is a bit boring perhaps. So what you could choose to do is, let me just break this out into index, volts, oops, it's spelt in a curious way, but not to worry, and watts. I've still not got that right. There we go, watts. And what we'll do is clear the string at each step, and we'll create a string. So for the first one, it's just an index. The second one, it's going to be the voltage reading and the letter V. And the third one, a watts reading and the letter W. Of course, reading watts is a bit of an odd thing to imagine. I suppose in reality, we're probably going to be reading current and multiplying by the volts. But anyway, just for just for presentation's sake, let's assume that's right. And we'll use this same text writing statement in there, and there. And we just remove the multi-line, because now we want to draw a single line. Or we could leave it multi-line, I suppose, and just change it to a number 1. So, oh no, not number 1, sorry. But we're still number 5, because it's still 5 characters wide. Anyway, whatever. So yeah, either one way or the other. And let's change some of the colors. So let's say we want the first one to be red. We want to be transparent because we're on top of a graphics background still. Let's do the last one to navy. Let's leave the middle one as white. Quick drink of water. I think that's all. Oh no, I haven't done the Y offsets. So if we upload this code now, of course. Yeah, that's going to write the text all on the same line. So what we do need to do is just add the Y offset. So the first line is fine, but for the second one we want to add 32 pixels because that's the height of one character. And the third row we need to add 64, the height of 2 characters. And then just reload that code. And that will do the job. So you can see there, that's another technique for writing out the text. Instead of multi-line and doing it in one statement, you could choose to write the text line by line. The advantage to that is you can have different colors. Yeah, I mean you could refine that even more by writing character by character if you wanted to and have different colors for each character, but How far do you go? So I think that's all. Oh, well, let's do some summary data because there's space. Let's say summary data in there. And what we'll do is grab this. So we just do another dividing line. It's just a horizontal line. And we've just moved the Y position down again now. So we've gone 132 down below the second row of boxes. 100 because that's what we've used before, and 32 because that's the height of a character, so that just seemed like a reasonable space. But you can obviously adjust that visually however it looks nice to you. So yeah, draw a line. We've just added up the total yield, which is the total watts divided by 1,000 to give us kilowatt hours. And then we just write out some summary text. So there's outside temperature, and I'm just reading the temperature from our fake temperature sensor. Obviously, in the real world, you'd add an actual temperature sensor to your project. And then we just write total yield, which is just the total of yield. We're just adding it up here for kilowatt hours. So that is, I don't believe there's any new features in there otherwise. So we'll just upload that to the device. And there we are. So what we are seeing here is how to create your own graphical interface, how to use multi-line text, how to use fonts with backgrounds, which I've not necessarily shown you, but we could actually let's just say that it's going to be hot out. Let's just change let's make it clear. Okay, I'll just quickly change that. So I've just changed the colors around for the outside temperature line. So now we've got a red background. So, and you can see what I've done there, hopefully. I've just changed, so I've set the background color to red and the text foreground color to white. And so, you know, you could perhaps automatically show it as a red background if the color is, you know, less than a certain value, and you might decide to go to, you know, a green, a lightish green if the temperature is more bearable. You could do things like that, changing the color as you go. I haven't changed the color in both locations, but you get the point. So yeah, so showing you how to draw text, how to use background and foreground colors, how to use transparency, how to have multi-line text, how to load images, how to draw lines, horizontal. I've not shown vertical, but it's the same idea. So drawing on the graphics is nice because you could create your own buttons and sort of objects, and then, you know, in a graphics package and icons, and then draw text over them if you wanted to. So quite a nice feature. Yeah, and then finally, let's just change the resolution here back to 480, which is the resolution of our small parallax monitor. And I'll just load the text in again. And now if we just switch over to our camera and get rid of the inlay image, and just move the camera slightly, there we go. Yeah, so now you can see how it looks on the monitor in all its glory. So hopefully that will be useful. All the code will be on our webpage in a zip, so you can download and experiment. As I said, ask any questions at forums.parallax.com. And yeah, thanks for watching.